Hello, and I want to welcome you to a discussion on linear equations and rational equations. So let's get started. Okay, so you may be given examples to solve linear equations. And to do that, here's the procedure. If an equation contains fractions, multiply both sides by the least common denominator to clear the equation of fractions. Use the distributive property to remove parentheses if they are present. Simplify each side of the equation by combining like terms. Get all variable terms on one side and all numbers on the other by using the addition property of equality. Get the variables alone by using multiplication property of equality, and then check the solution by substituting it into the original equation. So example 1, solve the following linear equation. What you want to do first is you have 3x plus 5 equals 17. Start by subtracting 5 on both sides of the equation. So you have 3x equals 17 minus 5, or just 12. Now to get x by itself, divide both sides by what's in front of x, the coefficient of x, which is 3 in this case, so divide both sides by 3. So you're left with x is equal to 12 over 3, or x is just equal to 4. Okay, moving on. For number 2, we have 2x minus the quantity 2x minus 2. All that equals 0. So to get started, the first thing you'd like to do is you see this negative out in front of the parentheses. You can think of that as just a negative 1, and you want to distribute that using the distributive property across everything inside the parentheses. So to do that, you have 2x minus 1, that's the minus 1, times 2x. Then you have your minus 1, because we're distributing it again, times the negative 2 that's still in the parentheses, and then we're going to have our equals 0. We go through and simplify. Now we have 2x, then we have negative 1 times 2x, we're just going to have negative 2x. They have a negative 1 times negative 2, that gives us just a positive 2, equals 0. Okay, so 2x minus 2x just leaves us with 2 minus, or equals 0, and 2 does not equal 0. That is a false statement, so the answer to this is no solution. It says whatever you put in for x, you're going to get something that cancels out, leaving you with something equaling 0, making it a false statement. Okay, looking at number 3, we have several things going on here. We have 3 times the quantity x minus 3 plus 4 times the quantity x plus 2, all that equals 13. So what you want to do is use the distributive property, take this 3 and multiply it across everything inside this set of parentheses. Then you're going to take this 4 and multiply it by everything in these parentheses, and then we're going to have to simplify with our variables and see what we get for that. So to get started, we have 3 times this x that appears first. I'm so sorry about this. Plus 3 times that negative 3 in the parentheses. Then we have plus 4, because we're in the set of parentheses. Multiply by the first x that appears. Plus 4 times the 2 that's still in the parentheses. We're going to have equals 13. Okay, so now let's go through and simplify. 3 times x is 3x. 3 times negative 3 is negative 9. 4 times x is 4x. Okay, so now we have 4 times 2, and that is 8, equals 13. Okay, so if we go through and simplify, 3x plus 4x is 7x. Negative 9 plus 8 is negative 1, equals 13. Okay, so to get stuff away from x, we have to work farthest away from it. So this negative 1, we want to add 1 on both sides. So 7x is equal to 13 plus 1, or just 14. Finally, getting x by itself, divide by 7, the coefficient of x on both sides of the equation. So you're left with x equals 14 over 2, or excuse me, 14 over 7, or x is just equal to 2. Okay, and finally for number 4, we have some fractions. So we have 3y over 4 plus y equals y over 2 minus 3/4. So you have to think to yourself, what is the least common denominator? Well, it looks like in this case we're going to have 4. So that means we have to write everything as a fraction over 4, where 4 is the denominator. So in this first case, 3y over 4, you can just leave that as it is because 4 is already in the denominator. Okay, with this plus y, you can think that as a coefficient of 1 out in front of y. And how can we write 1 where 4 would be in the denominator of a fraction? Well, just think of that as 4 over 4. And y is just tagging along on top. Okay, so we have this next part of y over 2. So we want y on top, and so the fraction reduces to 1/2, because that's like a 1 over 2. So we can think of that as an unsimplified fraction of 2 over 4, because if you simplify this part, it would reduce to 1/2. Right, and simply just write that last part, that minus 3/4, because it's already having a 4 on the bottom of the fraction. Okay, so let's go through and simplify on this left side. 3y, or 3/4 y plus 4/4 y gives you 7y over 4, as we just added the numerators. Okay, equals 2y over 4 minus 3/4. So, to get the two y-fourths on its own, to get to the other side, you want to subtract it on both sides. And that's going to leave you with 5y over 4 equals negative 3 over 4. Okay, now to get y by itself, we're going to multiply by the reciprocal on both sides, and the reciprocal of the coefficient of y would be 4 over 5. So we're going to multiply 4 over 5, because what that's going to do is going to get y by itself, and I believe we're going to see something very unique and interesting happen on the right side of the equation. Okay, so over here, through cross multiplication, those 4's will cancel out, and so will those 5's. So you're just left with y on the left side. And over here, if you do the same thing, the 4's cancel out due to cross multiplication, so you're just left with 1 times negative 3 on top, or just negative 3, over 5 times 1, or just 5. So we're leaving y being negative 3 over 5. Okay? So recall that the denominator of a fraction cannot equal 0. When a denominator is equal to 0, the expression is known as undefined. When solving an equation, if a proposed solution makes the denominator 0, then there is no solution to the equation. So let's take a look at these two examples. We have 3x, or 3 over x equals 1 over 3x plus 3. So we're dealing with rational equations, and what we want to do is multiply by the LCD on both sides of the equation. So what is the LCD? It is what all the denominators have in common. So if over here this 3, just write that as 3 over 1. And if you look, this one has an x, this one has a 3x, and this is a 1, and all those can go into 3x. So we want to multiply 3x by everything inside that equation. So 3x times 3 over x equals 3x over 1 over Actually, I wrote that wrong. It should be 3x plus 3x times 3. So, as we can see now, these x's cancel out, leaving you with 3 times 3, which is 9. Over here, the 3 x's cancel out on top and bottom, so we're left with 1 plus 3x times 3, that's just giving you 9x. So, to start getting stuff away from x, we have to work farthest away. We have this 1, so let's subtract it on both sides of the equation, giving you 9 minus 1 is just 8 equals 9x. To get x by itself, divide by 9 on both sides. So for your solution, x equals 8 over 9. And we have to think to ourselves, what kind of restrictions would this have? That means what would make the denominator 0? Well, if we let x equal 0, this would make this part undefined and we cannot solve it. So the restriction would be x equals 0, or x cannot equal 0. And since we found that x equals 8 over 9, we found that restriction, that our solution fits inside the restriction. Okay, for this next one, we have x over 4 equals 2 plus the quantity x minus 3 all over 3. So we can rewrite that this part right here is 2 over 1. So we have 1, 3, and 4 as denominators. What do all of those have in common? Well, 3 cannot go into 4 and 4 cannot go into 3. 1 can even work in either one of those. So if we multiply 4 and 3 together, we get 12. So that means that 4 can go into 12, 1 can go into 12, and 3 can go into 12. It's the least common denominator. So now just take 12 and multiply by everything inside the equation. So 12 times x over 4, 12 times just 2, plus 12 times the quantity x minus 3 over 3. So, over here, if we use cross multiplication, 4 can go into itself once, and 4 can go into 12 3 times. So we're left with 3 times x, which is 3x. Over here, 12 times 2 is just 24. Using cross multiplication for this last part, 3 can go into itself 1 time, 3 can go into 12 4 times. So we just have plus 4 times the quantity x minus 3. Because we could cancel out anything with x minus 3. So let's go through and use the distributive property to multiply this 3 by everything inside the parentheses. So we have 3x equals 24 plus 4 times x plus 4 times negative 3. Now let's go through and simplify everything we see. 3x equals 24 plus 4 times x, or just 4x. Okay, and we have 4 times negative 3, or just negative 12. Simplifying further, we have 3x equals 24 minus 12, or just 12 plus 4x on the right side. To get stuff, we want to get our x's together, so let's subtract 4x on both sides of the equation. So we have negative 1x equals 12. Okay, so finally, to get x by itself, divide by a negative 1 on both sides of the equation. So x equals negative 12, because 1 divided by negative 12 just gives you, or 12 divided by negative 1 is just negative 12. So now I have to think about restrictions and see if our solution works. So what number would make the denominator go to 0? We have 4, 1, and 3, so there's nothing we could plug in for x to make the denominators go to 0, so the restrictions were none. So it didn't matter what we got for x, it would still work to make the denominators equal anything but 0. So our solution for x works in the restrictions.